In the early 2000s, television producers placed groups of young women into intensely monitored, heavily constructed environments. The success of these experiments relied on a very narrow set of metrics. Producers optimized their sets to manufacture the perfect photograph and drive up raw viewer ratings. When criticized for their methods, the creators argued they were simply operating a closed ecosystem. They provided exactly what the audience tuned in to watch, absolving themselves of any responsibility for the fallout. But the camera didn't capture the actual human toll. To stay competitive, contestants were pressured into cosmetic dental surgeries. They endured severe emotional trauma and lived in environments where sexual harassment was treated as a routine occupational hazard. Maximizing a single data point inside a fabricated vacuum creates a dangerous blind spot. The people running the experiment lose sight of the exploitation happening right in front of them. Today, we look back at those reality competitions with clear disgust for the conditions those women survived. Yet the technology industry is currently repeating that exact measurement error on a massive scale. Major technology firms are rushing to integrate artificial intelligence into our daily lives, and they are grading their models using their own isolated internal scorecards. Running a highly capable, adaptive system exclusively through sterile computational laboratories ensures that developers miss the actual fallout. Evaluating immediate lab results tells us almost nothing about what happens when the software goes live. We have to look past the initial output to see the downstream damage. Researchers evaluate new models by looking for what they call first-order effects. They run the software through a process known as benchmarking, which happens entirely in silico, meaning strictly within computer simulations. A benchmark tests a model against a static dataset, grading it on raw accuracy and processing speed. It operates exactly like a closed photo shoot, grading a single capability in a perfectly controlled vacuum. The problem with this approach is its reliance on predictable structure. When actual human users enter the equation, their interactions are messy and interdependent. The simulation cannot account for them. While these leaderboards dictate how developers define a successful launch, they offer an incredibly narrow view of how the technology behaves in public. The moment a model leaves the laboratory, it collides with the human variable. It has to navigate the complex realities of behavioral economics. People do not operate as perfectly rational actors. We experience choice overload when faced with too many options. We rely on mental shortcuts or heuristics to make quick decisions, and we heavily weigh the fear of losing something over the potential to gain. A responsive algorithm quickly maps these vulnerabilities. It feeds our reliance on shortcuts, making users highly susceptible to generated misinformation or tricking employees into executing system-wide ransomware attacks. If you build a system that only processes clean logic and static text, it will shatter the second it encounters actual human psychology. To fix this, independent researchers are pushing for a new evaluation ecosystem. They want to move testing out of the server farms and into real-world environments, a process known as testing in situ. This diagram maps the disciplines required for this new approach. By combining machine learning with social science, researchers conduct field testing and red teaming. They place thousands of human subjects into multi-session environments to observe how their behavior adapts to the software over weeks or months. This method forces evaluators to measure the entire contextual unit. They stop testing the isolated machine and start testing the system and the human working as one cohesive loop. Finding the secondary effects requires stepping away from isolated, single-turn prompts. It demands dynamic, observational science in active environments. The executives running the reality television empire maintained a flawless public-facing image and blamed the culture at large when their contestants suffered. Today's technology leaders are using the exact same playbook to justify shipping unvetted models. When developers ignore outside feedback before launch, they hardwire brittle performance into their products. The clean engineering snaps the moment it has to bear the weight of unpredictable human behavior. Optimizing for a single immediate goal creates a massive liability. It hides the systemic, long-term damage spreading through the real world. The software industry requires a literal reality check regarding how it measures safety. A capable safety evaluation leaves the sterile laboratory behind. It forces developers to navigate the collision between their code and the messy realities of a living society. If success remains defined by high scores on an isolated leaderboard, the builders will inevitably be blindsided by the actual impact of their creations.